In this video, we are going to talk about the modern view of the atomic structure. Following the famous experiments of the scattering of the alpha particles, it was established that almost all the mass of the atom is contained within this tiny volume, which is the nucleus. And the nucleus carries the positive charge of the atom, while the negatively charged particles reside within an empty space of the volume of the atom. So all the volume of the atom is an empty space in which the fundamental particles that are the electrons reside. So these red symbols are the one of the electrons. And further experiments showed that the nucleus is composed in turn of protons and neutrons. The protons are the carriers of the positive charge. So, as we see here, the nucleus is positively charged. These positively charged particles came from the protons, while the neutrons, as the name implies, they have no charge. They are not charged. These subatomic particles are not charged. So we can say that the mass or the protons, these subatomic particles, the protons and neutrons, account for almost all the mass of the atom. And also, as these subatomic particles are stuck together within this tiny volume, the nucleus, so they are not in contact with the outside world. Instead, the electrons that reside within the empty space are always in contact with the outside world. In other terms, they can be transferred to the outside world, or electrons can be added to the atom. And these operations results by the formation of the ion, of an ion. An ion is a charged atom. This ion can be a positive charged atom or a negative charged atom. So here we can see that we have three fundamental particles that are the electrons, the protons, and the neutrons that compose the atom in the modern atomic view. And now let's talk about the properties of these three fundamental particles. In this table, we summarize all their properties. We have one single electron, one single proton, and one single neutron. We can see that a neutron has approximately the same mass as the protons. Their masses are very, very close. And also, we can see that a single proton or a single neutron is about 1840 times greater than the mass of an electron. As we see here, it is extremely small when we compare the mass of the electron to the proton or the mass of the neutron. Also, the charge of electron is exactly the same as the charge of the proton in magnitude, but they are opposite in sign, because the proton is positively charged and the electron is negatively charged. The same thing for their relative charge. The proton bears a positive +1, and the electron has a relative charge of -1, while the neutrons a neutron has no charge.